Hello everyone, welcome to the channel Something Rational. Today I want to start the series of quadratic function features and solving quadratic equations. These questions I solve with my students in the class, definitely. So I wanted to record them as well. Either they can get benefit from these questions or my followers, they can get benefit from these questions as well. Since NJSLA is so closer, let's get started. So this questions about key features of quadratic functions. One of the questions here. Some of the question with calculator, some of them without calculator, definitely. If calculator is allowed, it's easy for us. But if it is not allowed, theoretically, we need to just know uh, what is behind the question or what is the context of the question. You can feel free to pause the video and you can try it by yourself first, or just pause the video and read the question first. As you see here in this question, quadratic function is given to us. This is the most primitive, just like quadratic function means that not transform or not carried to anywhere or not moved anywhere. As you see here, f of x is equal to x squared. So that is, we call it parent function, okay? So most of the students, they learn this parent function when they are in the middle school. So a kind of parabola which is passing through the origin, okay? So I don't want to explain what is f of x is equal to x squared. Definitely, as high school students, they must know what kind of graph it has. Question is here different. So by using the function f of x, in the question they obtain g of x and h of x. Okay. With a slight different, as we see here in the g of x, f of x plus k in parentheses, but in h of x, f of x is separate and parentheses aside, and plus k is out of the parentheses given to us. And k is non-zero real number. K is not equal to 0. If k is equal to 0, definitely there will be no change. If I put here 0, g of x and h of x will be similar. So, this question has two parts. Part A is show algebraically that g of x and h of x are different from each other, or different functions. There are just several ways, because since it's an open-ended question and there's a space here provided, so we can answer this question in several ways. Whether we can choose k as a non-zero real numbers. For example, you can choose k is equal to 1, k is equal to 2, or you can continue k as a non-zero real number as an expression. You can do it, okay? So in both ways, I will show it to you. Let's start with g of x. G of x is equal to f of x plus k. Okay, f of x plus k in parentheses. So it means that wherever I see x plus k in the f function is here. F of x is equal to x squared. So x plus k and x, I need to replace it. Okay, so f of x plus k square. Okay, so my g of x function is this. G of x is equal to x plus k whole square. What about h of x? H of x is given here. F of x is equal to f of x plus k. Okay. So what is f of x? F of x is given to us already, which is x squared. And k is aside there, x squared plus k. So when we just see them carefully, h of x is equal to x squared plus k, g of x is equal to x plus k whole square. Definitely they are different from each other. You can continue further and you can expand this. X plus k whole square means x plus k times x plus k. This type of multiplication you have been doing already. I want to just make it a little bit shortcut. So first term square plus double of the first term and the second term plus and the second term square, okay? But here, simply h of x is x squared plus k. As you notice here, they are different. Okay, let me just highlight this also. One of them is x squared plus k, 2k x and plus k squared, other is x squared plus k. They are different. Algebraically, you can prove this. They are different from each other. and you can type this in the provided space. Okay. Or you, since it's an open-ended question, you can replace k with a non-zero real number. Like you can choose k is equal to 1 or -1, or k is 2 or 3, something else like. So you can prove that they are different from each other. I hope you enjoyed the video. Thanks so much. So let's go to the part D.